In this presentation, I would like to review a few topics to help you prepare for the final exam. The topics that I'll cover are the new operator, the delete operator, and compiler-generated functions and operators for classes and structs. Let's begin with the new operator. Recall that the new operator allocates memory on the heap. This was similar to the function called malloc in C. You won't be tested on how to use malloc on the final exam, but it would be a good idea to be familiar with the name. By being able to allocate memory on the heap, it enabled us to have data structures like linked lists, as well as arrays that can change size. When you use the operator new, it'll return the address of the first byte of allocated memory on the heap. In some situations, new can actually fail. Most commonly, if your system has no memory left, new will be unable to allocate memory, and the way that you can detect this is by checking if the returned address is equal to null. For the programs that we develop in ENCM 339, it's not always necessary to check if new actually succeeded. That's because the amount of memory that are used by the programs we develop is quite small, and new should always succeed in these cases. However, if you are asked to determine if new succeeded or not, you should remember that if it fails, new will return the address null. So let's see a short example to illustrate this idea. The purpose of this example is to allocate an array on the heap of variable size. The size of the array will be determined using a command line argument. Remember that to use command line arguments, you give main two arguments. The first is an integer, which is the count of the number of arguments, and the second is a character pointer pointer, which represents an array of C strings. Those strings will be each of the words that the user typed on the command line. So for example, argv of 0 would be /a.out if the program running is called a.out. For the program, I expect only one extra argument after a.out. So I check if argc is not equal to 2, then I display an error message to enter the array size. If the user did enter the array size, I have to convert it into an integer using the function a to I, or ASCII to integer, and I pass it the second string in argv. I can use the new operator to allocate an array of type integer on the heap. Now if new succeeded, I will hold the address of the first byte allocated by new. If it failed, I will be equal to null, and we can detect that failure and quit the program. So the point to remember here is that if new fails, the address returned will be null. And now for delete. Recall that delete deallocates memory on the heap. This is like the function called free in C. And again, you won't need to know how to use free, but it would be useful to recall what the name of the function is. Delete comes in two forms, and the form that you use depends on how new is used to allocate the memory. If new is used to allocate an array, even an array with a single element, you must use the delete array operator. That's the delete with the square brackets after it. Anything else, you use the normal delete without the square brackets. One thing to note about delete is that it doesn't set the pointer to null after delete operates. This is important to remember if the pointer that's being deleted is going to be used again. I will use an example to illustrate this point, but before we get to that, the last thing to remember with delete is that it is safe to call delete on a null pointer. In most cases, if you have a pointer that's pointing to a random address and you call delete on it, your program would crash. But if the pointer you give to delete is pointing to null, which means that it holds the address of 0, calling delete on that pointer is safe and won't cause the program to crash. Deleting a null pointer will simply do nothing. This example follows the first example where we allocated an array of integers of arbitrary size. Once we're finished with the array on the heap, we should free it using delete. In the example, I simply output the address that I stores, before and after delete. You'll notice from the output at the bottom of this slide that before and after delete, I still holds the same address. If there is a chance that you could call delete on I again, that would cause a double free error, and your program would crash. This was an issue that I saw a few times in Lab 5 because the destroy function got called twice for some linked list, and if the head pointer wasn't set to null after being destroyed, a double free error could happen. The second half of the example shows that it's safe to call delete on a null pointer. So I has been set to null, and the output shows that I holds the address 0, and then delete is called on I. But that doesn't cause the program to crash. Because of this, it's not necessary to check if a pointer is null before you delete it. If the pointer is null, it will simply do nothing. It is okay to check if a pointer is null before deleting, but just note that it's not necessary. The last topic that I'll cover is compiler-generated functions, and this relates to classes and structs. And first, recall that the only difference between a class and a struct in C++ is that the default access level for a class is private, whereas the default access level for a struct is public. When you declare a class or a struct, if you don't declare any functions, the compiler will automatically generate 4 functions for you. A default constructor, which is a constructor with no arguments, copy constructor, which is a constructor that takes a reference to the same type of object, a destructor, which gets called whenever an object goes out of scope, or delete is called on a pointer to an object, and lastly, an assignment operator. The functions that the compiler generates are the most basic possible. So for example, the copy constructor and assignment operator that are generated by the compiler simply do member-wise copy, or shallow copy. If your class or struct doesn't use memory allocated on the heap, these default compiler-generated functions may be enough for your needs. Those 4 functions are the only ones that the compiler will automatically generate. It is possible for you to define your own operators, but those won't be generated by the compiler. Let's consider an example which uses a struct point that has 2 member variables, x and y. X and y are in the public section because point is a struct, and structs have default access level of public. That means that x and y can be used from outside of member functions. In that point declaration, there was no member functions declared, but the compiler will generate the 4 functions that I mentioned before. In the example, we can see where those default functions get used. When I declare PS, which is an array of pointers, that uses the default constructor. Recall that arrays always use the default constructor for arrays of objects. The compiler-generated constructor will allow us to declare that array, but we can't expect specific values for any of those points in the array. If you want each of the points to be initialized to a specific value, you would need to write the default constructor yourself and not trust the compiler-generated constructor. Next, when point P3 is declared, that uses the copy constructor to member-wise copy all the elements of PS0 into P3. Similarly, when P3 is assigned to PS1, that does another member-wise copy using the compiler-generated assignment operator. In this case, point is not using any dynamically allocated memory, so the default implementation for the copy constructor and assignment operator is fine. And lastly, the if statement compares if 2 points are equal, and the test is performing if both points x and y are equal. Although we could write our own equality comparison operator, which does the same thing, it's not implemented by default. This is just to refresh that only those 4 functions that I mentioned before are automatically generated by the compiler. In this presentation, I reviewed some ideas related to new and delete operators, as well as covering compiler-generated functions, which were the default constructor, copy constructor, assignment operator, and destructor.